Well, we're just having fun here in the studio on a Tuesday evening. Dave, if you would go ahead and mute everyone, please. And then see if you can find out how to spotlight me. We're having Zoom issues. This is a ham radio class, believe it or not. My name's Gary, ham radio call sign Whiskey 4 Echo Echo Yankee. And we're going to go over the very last chapter in our book, this one, the American Radio Relay League General Class License Manual, 10th edition. Yeah, that's the book we use. It's great because it has all of the questions and all of the answers that might be on your 35-question multiple choice test right here in the book, and explanations about what's going on. And then we cover the questions and answers in class as well. So before we get started tonight, I want to give a shout out to one of our YouTube students, Mike Barufa, N8TLS, passed his general, 100%. Way to go, Mike. We're so proud of you. So yay. And he's watching us tonight on YouTube. So just pat him on the back, all you folks watching us on YouTube. So the plan for tonight is that we'll cover Chapter 9, the safety chapter, and then we'll take a 5-minute intermission, and we will come back and take a practice test together. 35 questions, and we'll see how you do, how we did as instructors. And then next week, if you'd like to come back, we'll have 2 more practice tests that we can take together. You'll grade your own paper, or don't have to share that with anybody else, but just gives you a chance to practice and get used to the questions that you're going to see at your actual exam. So I am going to postulate tonight something. Ham radio is a hobby. Yes, indeed. Ham radio is a public service. It's a radio service of the FCC, but I postulate that ham radio is also an adventure. An adventure? What? Well, the definition is an unusual and exciting, okay, ham radio, and typically hazardous experience or activity. Typically hazardous? Well, if I'm climbing, that might, rate as an adventure. Or if I'm hiking in the mountains, yeah, okay, I could see that as an adventure. Or I've got my big sailboat, yeah, I'm out there. But sitting behind my radio is an adventure? Well, yes, because we in amateur radio don't just sit behind our desks, but we deal with all sorts of hazards. Climbing is one of them. If you're going to put up a radio tower, less electricity, electrical systems, and hazardous materials, and RF emissions, or radio frequency emissions. All of those things make up the typically hazardous part of ham radio. And what we're all about tonight, covering Chapter 9, is hazard prevention and mitigation. Be aware of the hazards, and then do your best to mitigate those as well. So we're going to get started with section 9.1, which is electrical safety. And I want to give a shout out to Tom Walton, an old friend of ours, KZ4M, who actually put this safety presentation together, and I've kind of modified it and built on it. So thanks, Tom. So with electrical safety, and a lot of this is just going to be review, but don't work on live equipment unless it's absolutely necessary. Please avoid working alone if you're working on energized equipment. And never assume that equipment is off or de-energized. Dave's playing around with Zoom tonight, and I don't know where he's gotten this, but he's not sure either. Okay. So never assume that equipment is off or de-energized. Check with a meter or some sort of tester to make sure that you know whether there's a live circuit going on. Tom recommended to Tom Walton that you have a master station on-off switch, so that therefore if you're shocked, rescuers could remove power first so that they're not exposed to shock. The switch should be labeled clearly, and let your family and friends know where it is, so that if, God forbid, the worst happens, that you have a way to turn off power to your station. Can everybody in the Zoom classroom see me okay? Just go ahead and unmute and say yes, or can you see the presentation okay?
Yes.
Yeah.
Okay, good.
Presentation's fine.
Good, thank you so much, okay. So with electrical safety tips, some more, when you're working on feed lines or antennas, make sure that a transmitter or amplifier can't be activated. Someone else in your ham shack can't transmit while you're working on an antenna. In industry, they call it a lockout tagout procedure. And so we'll talk more about that here in a little bit. If you're working on energized equipment, we say keep one hand in your pocket while probing or testing. You want to make sure that the electrical current doesn't flow through your heart. Wear shoes with insulated soles, and remove unnecessary jewelry that might fall in and contact an energized circuit. Also, with rotational or mechanical things, jewelry can be a hazard. So the most dangerous currents are those that travel through the heart. Those are arm to arm or arm to foot. And electrical energy, the flow disrupts the heart's normal beating rhythm. And 60-cycle household current is actually more dangerous than DC. It penetrates the body easily, and it can disrupt heart activities. Now, I worked for the Voice of America for 20 years at overseas transmitting stations, and there were some unfortunate, tragic things that occurred both at our domestic stations and overseas. And experienced technicians who actually maybe got complacent were injured or killed. So some lessons learned from the Voice of America, which I'll pass along to you here. Do not assume that safety systems are working. Check them. We had a technician who was killed by a transmitter in Greenville, North Carolina, who thought the bleeder circuit for the high voltage should have taken the high voltage down, but it was defective. The bleeder resistor system had opened up, and he was shocked and killed. Also, don't ignore having someone else there with you who can, if nothing else, call 911. We call that the two-man rule. Again, the same technician in North Carolina, it was a short shift. They didn't have enough people, so he went out on his own. Just because you got away with an unsafe practice in the past does not mean you can do so again. We had a technician in Greece who had always made measurements inside of a live transmitter cabinet, and it caught him and killed him. So you can't enjoy life if you throw it away. So I just want you to be extra special careful. Electrical safety is dealt with by local electrical codes, and also the National Electrical Code sets up certain criteria for electrical safety. Part of that is how you wire your house, and knowing the right way to wire an outlet. I can't tell you how many times I've found outlets that have been wired backwards, with the hot where the neutral should be and the neutral where the hot should be. The black wire, the black insulated wire, is the hot wire. And in this case, let me turn on my laser pointer. Whoops, where'd my... And on an outlet in the United States, the narrow or the thin, the short prong here, not so wide, that's the hot. That's where the hot side is. This is the neutral side over here, and this is a safety ground, the big round thing. So make sure that the receptacles are wired properly. You can buy inexpensive testers at a hardware store, and it's worthwhile going around and checking all your outlets. You might be surprised, because safety equipment can't work if the hot and neutral are reversed. If equipment has a metal chassis, we say connect it to a ground wire or terminal. If you've got equipment in your ham shack, bond them together in this way. Use 3-wire cords and plugs. Both of these steps will prevent hazardous voltages from appearing on the chassis of your equipment. And use wire and cable that is sufficiently rated for the expected voltage and current. So the current rating of wire is called its ampacity, the capacity for carrying amps. And the two most common sizes of house wiring are number 12 American wire gauge, and number 12 is for 20 amp circuits. It's actually bigger or thicker than number 14 American wire gauge, which is appropriate for lower ampacity of 15 amp circuits. And just here's a slide of the various American wire gauge sizes and all the way up to 3/0, which is down there on the bottom. Protective components, fuses and circuit breakers. They'll prevent equipment damage and fire by removing voltage when there's a current overload. Always use fuses rated for the voltage and the current that's specified. Place a fuse or a circuit breaker in the hot wire, never in the neutral wire, because if it blows on the neutral side, it still doesn't remove power to the device. So always keep that in mind. And if you're going to be using an amplifier, a lot of linear amplifiers are powered by 240 volts. The 240 volt AC circuits have two hot wires, and they have dual circuit breakers, as you see here, and the circuit breaker is placed in the two hot leads to protect the circuit that's involved. If you have that high-powered linear amplifier and it's a tube-type amplifier, you're going to probably have about 3,000 volts present inside, and so they're likely to include safety interlocks. These are switches that prevent dangerous voltages from being present when a cabinet or an enclosure might be opened. When you take the cover off of it, the switch activates and shuts down the high voltage sections. Interlocks physically disconnect high voltage or RF when they're activated, but make sure that they're working properly, because don't trust it with your life. And never bypass an interlock during testing unless you're instructed to do so and when you know what you're doing. Here's an alpha amplifier, which is one of the more popular tube-type amplifiers. Looking straight down on top of it, you can see the tubes used for output up here. But here, that's the AC safety interlock switch, which opens when you pull the cabinet top off to get inside. So keep that in mind. If you're wiring your house, or you have a house now, you may see these ground fault circuit interrupters. They will trip when there's an imbalance in current between the hot side and the neutral side. And they can be sensitive to just a few milliamps. And why is that important? Well, because all of the power coming from the hot, all the current, if it doesn't return on the neutral, then that means it's going someplace else. And that someplace else might be a human. It might be you. So this is how a GFCI has a transformer that's monitoring the two and will sense the differential between the two. And if it goes above a few milliamps, then it will trip. So GFCIs are important for life safety. So we talked earlier before class, some people are getting involved in Field Day, which is the third full weekend in June, and generators are always or typically used for powering ham radio equipment at Field Day. If you're going to be using a generator, make sure you're using it in a well-ventilated area. Have it installed outdoors, away from living areas. Exhaust fumes can be drawn into air intakes or windows, and we're concerned about carbon monoxide poisoning from the generator. So you also might install carbon monoxide detectors inside where there's living spaces. When you're going to gas up the generator, make sure the generator is turned off, let it cool down a little bit. Refueling should be done by a team of two. One person equipped with a fire extinguisher, and then store the fuel well away from the generator, and a fire extinguisher should be kept away from the fuel as well. If you're going to be powering your home during an emergency, like we had Hurricane Helene come through here, the upstate of South Carolina, if you're going to power your house, make sure that you're disconnected from your utility power lines. One way to do that is actually to pull the meter out of its socket on the outside of your house. That will physically disconnect your house from the lines. You do not want to connect a generator up to your house wiring while still connected to the lines, because you can backfeed the lines and you could injure a lineman. So that's not anything that you want to do. So just keep that in mind. Now, many generator installations at homes have a designated input for a generator, and they also have disconnection switches that serve the same purpose as pulling the meter. Shocking! And this electrical is not the only thing that can be shocking. Lightning can be shocking. So you want to consider lightning protection. It's fire prevention for your home. It reduces or prevents electrical damage to equipment. The best defense is to pull cables off of your equipment, the power cables or antenna cables, if you can do that before a storm occurs. Now, if you can't do that, or it's a site that you need to keep up all the time, then surge arresters mounted in a controlled environment like this panel with this grounded copper plate on the back. These are surge arresters for antenna lines here. These have gas discharge tubes inside that will clamp the line if it detects voltage over a certain threshold. And that clamping action can help prevent lightning damage to equipment. If you're going to put one of these systems in, make sure that it's installed outside the building. You do not want to invite lightning inside your building, and all of the grounding and straps and whatnot should be outside. Grounding connections should be short and direct as possible, and all lightning rods, or grounding rods I should say, should be bonded to other safety grounds and other earth connections using mechanical clamps or CAD welding, which is a high temperature welding process. Lightning rods bonded together keep the electrical potential all uniform throughout the system. You do not use solder to make these connections, because solder joints may be destroyed by the heat of lightning. So it's not appropriate in this case. But grounds are bonded together. Here we have a tower. Each of the tower legs is sent to a ground rod, an 8-foot ground rod driven into the ground. And then each of the ground rods is connected together as well with this circle of wiring here. That's the proper way to connect up grounds together. And then, as I mentioned, mechanically bond them or CAD weld. This is a CAD weld system down here at the bottom, never soldered. Oh, and did I say, put these lightning arresters outside the ham shack. All right, I've got a revelation for you. Come back to me just for a second, Bruce. Your mother was right. If you're going to be doing soldering, for example, in your workshop, if you're going to be putting connectors on cables or working on a piece of equipment, think about the solder. Solder is lead and tin, probably within a rosin flux inside. Lead poisoning. So your mom was right. After you get done doing all of that activity, wash your hands, because you have the potential for lead poisoning when you're using solder, a lead-tin mix. All right, let's answer some questions, see how we're doing. So why should solder joints not be used in lightning protection ground connections? Yeah, a soldered joint will likely be destroyed by the heat of a lightning strike. And which wire or wires in a 4-conductor 240-volt AC circuit should be attached to fuses or circuit breakers? Yeah, only the hot wires, yes. And according to the National Electrical Code, what is the minimum wire size that may be used for wiring with a 20-amp circuit breaker?
Charlie.
Yep, number 12, American wire gauge number 12. And which size of fuse or circuit breaker would be appropriate to use with a circuit that uses AWG number 14?
Delta.
15 amps. Great, you got it. And where should the station's lightning protection ground system be located?
Bravo.
Yeah,
Bravo.
outside the building. And which of the following conditions will cause a ground fault circuit interrupter to disconnect AC power?
Bravo.
It is Bravo. Current flowing from one or more of the hot wires directly to ground or through you to ground. So which of the following is covered by the National Electrical Code?
Charlie.
Yeah, electrical safety, that's what it is dealing with. And which of the following is true of an emergency generator installation?
Delta.
Not Delta.
Oh,
Alpha.
Alpha, yes, the generator should be operated in a well-ventilated area. The generator doesn't need to be insulated from ground, and fuel should not be stored next to the generator, but should be stored some ways away.
Should be insulated to ground.
Well, can be connected to ground. And many generators are recommended to be connected to a ground rod. You don't always see that, however. So which of the following is a danger from lead tin solder?
Alpha.
Indeed. Lead can contaminate food if hands are not washed carefully. So which of the following is required for lightning protection ground rods?
Delta.
Yes, Delta, they must be bonded together with all other grounds. And what is the purpose of a power supply interlock?
Charlie.
Delta.
Well, it's Charlie, actually, to ensure that dangerous voltages are removed if the cabinet is opened. It doesn't have anything to do with the voltage regulation or if there's too much voltage. So where should lightning arresters be located?
Alpha.
Yeah, where the feed lines enter the building on the outside. All right, moving on. Section 9.2, radio frequency exposure. All right, what stations must comply with the FCC's rules dealing with radio frequency exposure? All stations, not only amateur stations, but all stations with a time averaged transmission of more than 1 milliwatt. They have to, abide by these rules. So I like to use this analogy, but you got to be of a certain age to remember the old 100-watt incandescent bulbs. Remember these light bulbs? If you put your hand up close to the light bulb, in fact, if you put your hand on the light bulb, you're going to get burned. But if you are able to move away, you can feel the radiant heat, and you can move away further. Okay, maybe you only feel a little, and you're far enough away you don't hardly feel anything at all. Well, your antenna, your transmitting antenna, is the light bulb. And we have to keep people away from the antenna so that they can't touch it, number one, or they'll get burned with a radio frequency burn. But we also want to make sure that people are far enough away so that the radiant energy doesn't cause a problem. Exposure to radio frequency energy at low levels is not hazardous, but it does cause heating of human tissue. Factors that we consider are the power level, the frequency of the signal, the average exposure time, and the duty cycle of the transmission. And they're the primary factors that determine how much RF a body will absorb, power density and frequency being the prime. So radio frequency energy heats body tissue, which is why I say ham radio operators are more beautiful than the average because of all the RF. Okay, that's just my clue. But Heating from exposure to RF signals is caused by the body tissue absorbing RF energy. Power density is measured in milliwatts per square centimeter. And if you have an area of a certain square centimeter range and you know the power density, you can calculate the amount of power that is being absorbed, which is down there on that bottom portion of the slide. You don't have to do this for the test. But power density, it's kind of obvious. It's like the light bulb. It's going to be highest near the antennas and in the directions in which the antennas have the most gain. Increasing your transmitter power is going to increase the power density, yeah. And increasing the distance away from an antenna is going to lower the power density. So some terms of art here are the specific absorption rate. That's the rate at which energy is absorbed from the power to which the body is exposed. And safe levels of SAR are called the maximum permissible exposures. And that varies with frequency and as established by the FCC. And body parts absorb RF best when their dimensions are similar to the wavelength of the energy, which is why, and this table is in your book on page 9-10, the VHF frequencies, 6 meters to 2 meters, that region, which corresponds to body size approximately, is the most sensitive. It's where the body absorbs the most radio frequency energy. So on this chart, we have power density here on the vertical scale in milliwatts per square centimeter, and we have frequency on the horizontal scale. So here's 3 megahertz, here's 30 megahertz, here's 300 megahertz. Remember, 30 to 300 megahertz, that's VHF, and going in higher. And the lines you have here are the uncontrolled and controlled areas. We'll talk about that in a second. And so acceptable maximum permissible exposure for an uncontrolled area is at this level on VHF, and it's at this level in a controlled area. And the big difference there is controlled areas, people know that there's radio frequency energy being emitted. Uncontrolled areas are where the average person would not know that there's radio frequency energy being emitted. RF energy is averaged over a time interval because the body responds differently to heating for short and long duration exposures. And time averaging evaluates total RF exposure over a time interval. So we say it's averaged out. And the things that will determine RF exposure are the duty cycle of the transmission. If you're a broadcaster and you're transmitting with a 100,000 watt transmitter and you're broadcasting 100% of the time, well, your duty cycle is 100%. Ham radio operators, okay, we're operating at a much lower level, but we're also receiving as much as we're transmitting typically. So you'd say that our duty cycle is at least 50%. Then there's mode things that we'll talk about where some modes are 100% transmitting all the time and other modes are modulated, which are lower. And then the transmitter power sets the power density. So as hams, we have to, by law, by regulation, estimate exposure and evaluate our stations. Certainly the first time we put our station together, and then any time that we make changes. If we are using higher power or make changes to antennas, we have to do these routine evaluations. It used to be that we didn't. It used to be that if you operated your station with these power levels on these frequency bands, 160 meters, all the way up to microwave, that you did not have to perform an evaluation. This was during an interim 2-year period. This kind of gives you a general feeling of where you might want to begin to make evaluations. But no matter, if we're over 1 milliwatt, we have to do an evaluation. And there are 3 ways that you can do the station evaluation. One of those is to use calibrated field strength meters and calibrated antennas. Another is that you can use computer modeling to determine exposure levels. That's the one that most hams use. And the third way is to do hand calculations based on FCC Office of Engineering Technology Bulletin 65. So here's a calibrated meter and calibrated antenna that I bought off of Amazon. And it works down to 10 megahertz and then up into the microwave region. We said that VHF, between 30 and 300 megahertz, that's the most sensitive area. So this meter is great for that. And $271 was what I paid for it back in the day. And okay, that's a lot of money for one ham to buy, but okay, I'm kind of in the business, so to speak, and so I wanted to have it. I also had a situation at my old QTH where I had a 2-meter antenna directly above where the ham shack was, and I wanted to know, am I safe? Am I within requirements? So I'll show you the meter. It's right over here. Let me just show it to you. So $271, that's probably more than one ham generally would want to spend. But how about your ham club? This is a requirement. And so your amateur radio club, if they've got, they're collecting dues and they have a treasury and whatnot, this might be a great thing for a ham club to buy and then be able to loan out to hams as they need it, as they make changes to their station in order to make sure that they are compliant. And when you buy these, it comes with a certificate of calibration, and it has a calibrated meter and a companion calibrated antenna. This comes off. There's a carry case as well. And when I go out, I also have the chart that I take with me so that I can keep tabs on what's going on as far as, am I within the minimums or maximums for permissible exposure? So that's one way if you have one of these calibrated meters and antennas. Another way is by doing hand calculations using the FCC's OET Bulletin 65 and 65B, and the URLs for these are down below, PDF versions of them. 65B was written specifically for amateur radio. So if you're into that sort of thing, you can do that. All right. 90% of hams doing this are actually, though, going to use probably online exposure calculators. And ARRL has theirs here, where you input information about your station, the frequency range, the bands you're using, the power level, the types of antennas and what gain they might have, and then they will tell you the distance at which it's safe for humans to be around your station. The Lake Washington Ham Club also has one of these online calculators. And so these are useful, and then when you're done, just print out the results of that and put it in your station file. Put it with your manuals for your equipment. Theoretically, you're supposed to have an evaluation, although they don't specify in what form it's supposed to be in. It doesn't even have to be written. You just have to know that you have done an evaluation and you've considered it. Remember that the worst cases are VHF, the worst case power, legal limit power, and the worst case antennas are those with high gain. So anytime you change to a higher power, you increase your antenna gain, or you change your antenna height, then you probably should do an exposure evaluation, a new one. You do not need to do that if you reduce your power or you're at a station that's already in compliance. It's kind of repetitive here, but we just want to make sure that you get it through your head that you must take action to prevent human exposure to excessive RF fields. And this is nowhere more important than if you decided that you're going to install indoor antennas. If you're going to put an antenna up in your attic, that's all well and good, but you're much closer then to all of the inhabitants of the house. So it's really important there that you make sure that the maximum permissible exposure limits are not exceeded in the home. Okay, here's some more questions. So, what is one way that RF energy can affect human body tissue?
Alpha.
Yeah, it heats body tissue. Which of the following is used to determine RF exposure from a transmitted signal?
Delta.
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 We consider all of these, the duty cycle, the frequency, and the power density, indeed. And how can you determine that your station complies with FCC RF exposure regulations?
Delta.
Delta.
You can
Okay.
use the FCC OET Bulletin 65. You can do the calculations based on computer modeling or by measurement with a field strength meter that has calibration for the meter and the antenna. So what does time averaging mean when evaluating RF radiation exposure?
Delta.
Delta.
Yeah, it's the total RF exposure averaged over a certain period of time. And what must you do if an evaluation of your station shows that RF energy radiated by your station exceeds permissible limits?
Alpha.
It's kind of common sense. You have to take action to prevent human exposure to the excessive RF fields. And what must you do if your station fails to meet the FCC exposure exemption criteria? There is no exemption criteria anymore, by the way. The question pool was put together at the transition period. But what do you think you have to do?
Alpha.
Yeah, perform an RF exposure evaluation. So what is the effect of modulation duty cycle on RF exposure?
Bravo.
No, it's alpha. A lower duty cycle refers to the amount of time that you're transmitting. And so broadcasters have a 100% duty cycle. Amateur radio operators have probably a 50% duty cycle for transmitting. And then the modulation duty cycle has to do with the mode. If you're transmitting FM or radio teletype, that's 100% power all the time. If you're transmitting single sideband, that only puts out power when you speak and only at the voice peaks. So a lower duty cycle permits greater power levels to be transmitted because it's averaged over time. So which of the following steps must an amateur operator take to ensure compliance with RF safety regulations?
Charlie.
Yep, perform a routine RF exposure evaluation and prevent access to any high exposure areas. You can put up a fence, for example, around vertical antennas to keep people from putting their hands on it. So what type of instrument can be used to accurately measure an RF field strength?
Bravo.
Calibrated meter, calibrated antenna. And what should be done if evaluation shows that a neighbor might experience more than the allowable limit of RF exposure?
Charlie.
Yeah, and simply you take precautions to ensure that the antenna cannot be pointed in their direction, or you move the antenna to another location. That's what I would suggest you do. So what precautions should be taken if you install an indoor transmitting antenna?
Charlie.
Yeah, make sure that the maximum permissible exposure limits are not exceeded in occupied areas. And what stations are subject to the FCC rules on RF exposure?
Delta.
1 milliwatt or higher. Yeah, all stations with time average transmissions of more than 1 milliwatt. All right, our last section, outdoor safety is what they call it here. So installing antennas, the most important rule for installing antennas is place all antennas and feed lines well clear of power lines. Even when you're carrying the antenna to where you're going to set it up, make sure you're not carrying it so you can touch a power line. That could have a bad end. Safety rules dictate that if you're putting up a tower or an antenna system, it should be no closer than 10 feet from power lines if it were to fall. So if it's a 50-foot tower and it falls, you want it to be at least 60 feet away from power lines. Now, some people have said that's not enough. They have 150% of the height. Okay, for the test, it's the 10-foot rule. Don't run feed lines over power lines or service drops. If you're shooting lines through or over trees, Bruce came out and helped me put up a loop antenna the other day. There were no power lines out there, but we needed to be cognizant of where are the power lines because if you get your line up in a high voltage line, it could carry energy back down and get you. Also, make sure that you have a visual inspection before starting installation so you know where the lines are. People should not be able to come in contact with an antenna once it's installed. For most of our antennas, they're up high enough. You can't reach up 35 to 50 feet. Okay, you're good. If it's a ground-mounted antenna, place a fence around it or limit access in some other way. Read and understand assembly instructions before you're putting the antennas together, by the way, so that they don't fall down. A tower or mast that is used to raise antennas above buildings and other obstructions. If the mast or tower requires guying, keep all the lines and guys above head height if you can. Or if the guy anchor is low to the ground, make sure that you flag or fence the guy, just so people can't trip over it. Mm-hmm. Towers you may be required if it's a tilt over or a crank up tower to get a building permit. You need to comply with your local building codes. And as we saw earlier, towers should be grounded with separate 8-foot ground rods for each tower leg, with the ground rods bonded to the tower and to each other. Are you near a public use airport? If so, you need to comply with some other regulations. Your towers can be no more than 200 feet high in any case, but if you're close to an airport, you might not be able to go up that high. We mentioned this earlier, but if you're going to be doing antenna or tower maintenance, make sure that the transmitter or amplifiers are turned off. Disconnect the feed line. Climbers and ground crew must wear the proper safety equipment, personal protective equipment, safety harness for the climber, hard hats, gloves, and sunblock and goggles for those on the ground, boots and work shoes. Shoes are especially important if you're going to climb a tower. You don't want to be standing on a rung on a tower with tennis shoes. Your feet will start hurting like crazy. And always have enough crew to do the job safely. If you're new to tower maintenance, we'll volunteer to help other experienced hams because the goal is to be trained in proper tower climbing procedures and proper procedures in putting up antennas. If you're using a climbing harness, if you're going to be climbing, make sure that it's rated for the climber's weight. There's a sufficient number of lanyards to make sure that you can stay connected to the tower at all times so that if you accidentally fall off, you're still attached. And make sure that it's within the rated life cycle of a harness. Did you know that harnesses have life cycles? And beyond a certain time, their strength is not rated anymore, so you have to throw them away. Run through a safety checklist. Inspect all tower guying and support hardware. If you have a crank-up tower, make sure that it's fully nested or it has to be blocked with mechanical stops. You don't want it to guillotine down accidentally. Inspect all ropes and load-bearing hardware, such as pulleys that you might use to lift equipment up. Make sure that all electrical circuits that supply power to the tower are locked out and tagged out. And in industry, this is what it looks like. You actually put padlock on a circuit breaker to keep it from activating, and you put these signs on them. Do not energize. You can at home you can do something simple, but make sure that people know not to energize that circuit. All right, some more questions. Which of these choices should be observed when climbing a tower using a safety harness?
Bravo.
Bravo.
Yes, make sure that the harness is rated for the weight of the climber and it's within its allowable service life. What should be done before climbing a tower that supports electrically powered devices?
Bravo.
Bravo.
Yeah, make sure the circuits are locked out and tagged out. And that, ladies and gentlemen, is the end of Chapter 9, and it's the end of instruction from the books. Yay! You made it through the book, so I want to congratulate you. We're going to be taking an intermission here in a little bit, so get up, move around, but when you get up, grab a piece of paper and a pen or a pencil, and we'll take a 35-question practice test together. Oh, and if you'd like to donate to help the channel, we do accept donations at my website, w4eey.com. There's a PayPal link there. Classes are always free, but we do have expenses, and so anything that you might be able to throw our way would be greatly, greatly appreciated. All right, let's take our 5-minute break, and we'll be back with a practice test.
anybody who wanted to go in.
All right, we get a mute yell, but thank you. And we're back. Want to say hey to Rick Treadwell, who's watching us in Western North Carolina on YouTube. Hey, Rick. He had a good question in the chat about antennas and RF exposure. What about mobile? Yeah, that's an important thing. If your antenna is on your car and it's up high, it's less likely to have somebody grab onto it. But where I have my antenna mounted in the car, it's down lower because it's a mount, and somebody could go up and grab it while you're transmitting. So yes, you have to be concerned about that. And yes, you also need to should do an exposure evaluation. Are you subjecting yourself or your passengers to any RF hazards? So great question. Appreciate it very much. All right, so we're going to now go ahead and take a 35-question practice test. Practice test number 4. What? We haven't taken any practice tests yet. Well, we've taught this class before, and there are 3 other practice tests that we put together, and I put the PDFs of those practice tests in the folder for today's class. So if you go to the Dropbox folder, you'll find practice tests from the previous time we taught this class. They're still valid, still the same question pool. So here's number 4, and then we'll have 5 and 6 next week. There are 429 questions in the general class question pool. And if you had a test of 35 questions and there were no repeats whatsoever, you really needed to have at least 12 to 13 practice tests in order to cover all of these questions. So people ask me, well, how many practice tests should I take? 12 to 15 is not a bad number. And so we can count this test as one of those if you want. Please get out a blank sheet of paper. Number it 1 to 35, or number it as you go along. Just try to make sure you stay in synchronization. And then you'll be writing down A, B, C, or D as to whatever the right answer is, what you think it is. Remember that the answers are going to be in a different order on your actual test. So memorizing A, B, C, or D won't do you any good. So that's not what we want you to do. What I'm going to do is show you the question on the screen here, and then for those of you who have your cameras on, when you get done answering the question, if you just raise your hand briefly, that'll clue me to say I can go on to the next question. I appreciate that. So keep calm. You can do it. Let's go ahead and get started. Here's question number 1. Okay, and if you're in the Zoom classroom, just go ahead and unmute and tell me if I'm going too fast or too slow. Here's question number 2. And in your actual test, you'll have all the time you need. All right. And question 3. And here is question 4.
You went too fast. I didn't get to answer that one.
All right, let me go. I'll go back. We'll go back to all the questions if you need to at the end. If there's any questions you skipped or whatever, we can go back. But here's question 3 for a little bit longer, and then we'll go to question 4. All right, and now over to question 4. And here is question 5. And here's question 6. And now, question 7. And now over to question 8. And question 9. And question 10. And question 11. And question 12. And now, question 13. And question 14. Question 15. Question 16. And now, question 17. Okay, and question 18. Next up, question 19. And question 20. And question 21. And now question 22. And now question 23. Question 24. Question 25. And question 26. Here we go with question 27. And question 28.
Sorry, can you go back to 27, please?
Yeah,
Okay, thank you.
okay, 27. And then we'll go back to 28. Here's 27. All right, and we can still go back to it again. That's no problem. 28. And now question 29. Here is question 30. Question 31. And question 32. I see calculators clicking. All right. We can come back to it. Question 33. Okay, and next one is a pictorial or a schematic, I should say. 34, which symbol in this figure represents an NPN junction transistor? And question 35.
You back to 34, it's a little small print.
Yeah, I will do that in just a second. Let's complete 35, and then I'll go back. And due to the way we put this together, that's why we just kind of move ahead. But in your actual test session, you'll have all the time in the world you need. You'll set your own pace. So don't be freaked out about this. All right, let's go back to 34, which represents an NPN junction transistor. And then are there any other questions? If you're in the Zoom classroom, just unmute and let me know. We can go back to. Or if you're watching on YouTube, you can put it in the chat. Any other questions to go back to? Okay, I'm not hearing anything or seeing anything.
I'm sorry,
Yeah.
just getting back. How about 32, please?
Yes, 32. There you go.
Thank you.
And are there any other questions? Okay, well, let's see how we did. So, number one, what determines the performance of a ferrite core at different frequencies? A, the composition or mix of materials used, 1A. 2, what circuit is used to select one of the side bands from a balanced modulator? That would be a filter, 2C. And 3, how much must the power output of a transmitter be raised to change the S meter reading on a distant receiver from S8 to S9? Approximately 4 times, 3D. And what effect does a sudden ionospheric disturbance have on the daytime ionospheric propagation? D, it disrupts signals on lower frequencies more than those on higher frequencies. 4D. And 5, which size of fuse or circuit breaker would be appropriate to use with a circuit that uses AWG number 14? That would be D, 15 amps. 5D. 6, what are the restrictions on the use of abbreviations or procedural signals in the amateur service? They may be used if they do not obscure the meaning of a message. 6B. And 7, what sound is heard from an audio device experiencing RF interference from a CW transmitter? That would be on and off, humming or clicking. 7D. And 8, what precautions should be taken if you install an indoor transmitting antenna? Make sure that MPE limits, maximum permissible exposure limits, are not exceeded in occupied areas. 8D. And 9, what is the approximate length of the driven element of a Yagi antenna? Typically half-wave dipole, so half wavelength. 9C. And 10, which HF bands have segments exclusively allocated to amateur extra licensees? If you look at the color chart, there would be 80, 40, 20, and 15. 10C. And 11, what is the maximum symbol rate permitted for RTTY or data at frequencies below 28 megahertz? 300 baud. 11A. And 12, what is the approximate length for a half-wave dipole antenna cut for 3.55 megahertz? A couple ways to look at this. You could remember the formula, 468 divided by the frequency in megahertz, and give you the answer in feet. Or you could think about it's the 80-meter band, so a half-wave dipole is going to be 40 meters long, and meters to feet, and the approximate answer is 132 feet. 12B.
Sorry, what was the answer for 10 again?
Let's go back. 10C.
Okay, thank you.
Yeah. And 13, what is the Volunteer Monitor Program? It's amateur volunteers who are formally enlisted to monitor the airwaves for rule violations. 13D. And 14, what is another term for the mixing of two RF signals? That's heterodyning. 14B. And 15, which of the following describes a log periodic antenna? It's one where the element length and spacing vary logarithmically along the boom or spine of the antenna. 15D. And 16, what is required to conduct communications with a digital station operating under automatic control outside of the automatic control band segments? It means that a human has to be involved. The station initiating the contact must be under local or remote control by a human. 16D. And 17, what does an FT8 signal report of +3 mean? It's the signal-to-noise ratio is equivalent to +3 dB in a 2.5 kilohertz bandwidth. 17C. And 18, which mode is most commonly used for single sideband voice communications in the VHF and UHF bands? So it's above 9 megahertz, well above 9 megahertz, so it's going to be upper sideband. 18D. And 19, which of the following is opposition to the flow of alternating current in a capacitor? That's capacitive reactance. 19A. And 20, what type of modulation is used by FT8? 8-tone frequency shift keying. 20A. And 21, what is the voluntary band plan restriction for U.S. stations transmitting within the 48 contiguous states in the 50.1 to 50.125 megahertz band segment? That's the DX window. So only contacts with stations not within the 48 contiguous states. 21C. And 22, what is the purpose of the notch filter found on many HF transceivers? It's to reduce interference from carriers in the receiver's passband. 22C. And 23, what is the approximate maximum distance along the Earth's surface normally covered in one hop using the F2 region? That's 2,500 miles. 23A. And 24, what is the approximate forward threshold voltage of a germanium diode? That's 0.3 volts, 24A. And 25, when is an analog multimeter preferred to a digital multimeter? When adjusting circuits for a maximum or minimum value. You're peaking or nulling. 25A. And 26, what does the Q signal QRV mean? It means I am ready to receive, or I will be operating. 26D. 27, which of the following factors determine the characteristic impedance of a parallel conductor feed line? It is the distance between the centers of the conductors and the radius of the conductors. 27C. So this would be like ladder line. 600 ohm, 450 ohm, 300 ohm. And 28, which of the following components should be added to an inductor to increase the inductance? An inductor in series with the first one. 28B. And 29, why is skip propagation via the F2 region longer than via the other ionospheric regions? Well, because the F2 region layer is the highest region, 29B. And 30, who may receive partial credit for the elements represented by an expired amateur radio license? B, any person who can demonstrate that they once held an FCC-issued general, advanced, or amateur extra class license that was not revoked by the FCC. They can get their old license grade back by just passing the technician test. 30B. And 31, which of the following is a way to establish contact with a digital messaging system gateway station? You transmit a connect message on the station's published frequency. 31D. And 32, what is the RMS voltage across a 50 ohm dummy load dissipating 1200 watts? That would be 245 volts. 32C. And 33, which of the following describes the function of a 2-input AND gate? The output of the AND gate is high only when both inputs are high. 33C. And our schematic, which symbol represents an NPN junction transistor? That is symbol number 2. I can show it. Oops, I don't have my laser pointer on. There we go. This guy right here, number 2. That is a junction transistor, NPN junction transistor. So 34A is the answer. And finally, 35, in what configuration are the individual cells in a solar panel connected? Series and parallel. 35B. So the question is, did you have 26 correct or no more than 9 wrong? If you did, you passed. Double thumbs up. Yeah, I like that. All right. Excellent. Well, I want to thank you for being great students tonight. Does anybody have any chat or questions or comments or anything before we go?
I'll be ready to take a couple more tests next week.
That sounds good to me. Yeah.
Thanks for everything, Gary and Dave.
Yep, happy to help.
Absolutely. If you'd like to make a
And I'll see you
donation,
again this fall.
here are the links. If you take the laptop, Bruce is there. If you'd like to make a donation, just go to my website. There's a PayPal link. Would help us out a great deal. Until next week, then, we'll say 73, 2 more practice tests next week.
Thank you.
See you next week.
Thank you. Thanks, Gary. Thanks everybody.
Yep.
Great.
Thank you.